Hi guys, welcome to my YouTube channel. So before we get started, make sure to hit the like button, also subscribe to my channel. In this video, we will talk about revolutionizing transportation, electric vehicles, and the future. So make sure to watch the full video. In the United States, the transportation sector accounts for the largest share of greenhouse gas emissions, with petroleum fueling 91% of transport vehicles. These statistics aren't foreign to most people, yet our dependence on transportation isn't something we're willing to read off of. Luckily, in the past 30 years, the automobile industry has made remarkable progress in popularizing a new source of energy for our cars: electricity. Electric vehicles themselves, however, are not a recent innovation. In fact, Americans have been driving electric vehicles alongside their gas-powered counterparts since the 1890s. Unfortunately, convenience and cost have always favored the gasoline car, leaving the EV business struggling to keep afloat. In this article, I'd like to elucidate some of the environmental benefits and drawbacks of shifting to an EV, followed by insight into how we can achieve more affordable and accessible EVs that can be enthusiastically received by the average driver. Breaking down vehicle emissions. When investigating the environmental impact of a vehicle, it's important to consider two categories of emissions: direct and life cycle. Direct emissions are emitted through the tailpipe during the fueling process when the car is being operated. These are the emissions most people reference when discussing the benefits of electric vehicles. Cars with an internal combustion engine emit major pollutants, such as nitrogen oxides and carbon dioxide, which are known to be harmful to human health and air quality. Alternatively, the typical EV emits zero direct emissions. Even plug-in hybrid electric vehicles are generally cleaner since their efficiency results in less fuel burnt overall. Specifically, the efficiency in hybrid vehicles arises from their ability to turn off the engine when decelerating or stopped at traffic lights, something that can't be done in gasoline vehicles. Life cycle emissions, on the other hand, is a more comprehensive category that accounts for the vehicle's production, processing, distribution, and disposal. Given its breadth, it can be difficult to analyze, but there's no doubt that all vehicles, regardless of how they are powered, emit pollutants over their lifetimes. While both EVs and gasoline-powered vehicles share similar emission rates in maintenance, storage, and disposal, the discrepancy lies in the initial manufacturing state. For a conventional gasoline vehicle, a substantial portion of emissions is produced when petroleum is extracted from the ground, refined into gasoline, and distributed to stations. For an EV, the extraction and refining of rare earth metals for lithium-ion batteries is what accounts for most of its emissions. Interestingly, when examining the manufacturing stage in isolation, EVs can produce 15 to 68% more emissions than the comparable gasoline car, depending on the size and range of the vehicle. This is because extracting rare earth metals requires extreme amounts of energy, which in most parts of the world is sourced from fossil fuel. Such facts are certainly worrying. Although driving your Nissan Leaf might not directly harm the planet or your city's air quality, it may have already caused its damage before it even entered your home's garage. The cost of battery production. Fortunately, numerous studies have been conducted to show that EVs can still be the better option, despite their manufacturing procedure. The question at hand is whether the operational efficiency of EVs can offset the detrimental effects of battery production, and most experts agree that they do and will only continue doing so. The International Council of Clean Transportation in 2018 stated that in summation, the typical EV can produce 29% less GHG emissions than the most fuel-efficient gasoline car. This is because, in most countries, the operation of a car plays a larger role in lifetime emissions than manufacturing, paling the drawbacks of EVs in comparison to gasoline vehicles. Moreover, an EV's capacity to travel more miles with a given amount of energy allows for more efficiency. This enables an EV to offset its manufacturing emissions with a gasoline vehicle within 2 to 3 years of driving, depending on your region's electricity grid. In other words, the gasoline vehicle's direct emissions will balance out the increased EV emissions from its manufacturing phase in just a matter of a few years. For example, the production of a mid-size, mid-range, 84 miles per charge battery EV generates 15% more emissions than a similar gasoline vehicle. But across its lifetime, the use of electricity in lieu of gasoline to power the vehicle results in 51% fewer emissions. In regions with extremely clean electricity grids, those initial emissions from production can be negated within 6 months. And that's exactly where the potential lies. The emissions from an internal combustion engine are immutable, whereas the emissions produced from an EV rely largely on the electricity grid, which can be reformed. Although we're at a point where even the worst electricity grids in the US provide cleaner energy than gasoline power, many foreign countries with largely coal-based electricity can't say the same. Decarbonizing the electricity grid. The electric grid is a web of interconnected transmission and distribution lines that supply everyday users with electricity from various power-generating sources. Broadly speaking, the mainland US unites 3 grids: the Western, Eastern, and Texas, with each functioning quite independently of one another. The type of energy used in the manufacturing and charging of batteries depends wholly on the sources in the grid. For this reason, the impact of driving an EV in one state could be drastically different than driving in another. What's worse is that electric grids connect sources and users that are thousands of miles away. So while you may be a conscious consumer, your car might still be pulling electricity from a distant town that's bearing disastrous consequences. For example, a 2019 PNA's research shows that 40% of the carbon emissions for electricity usage in California were exported from another region in the country. What do you think of our video? Let me know in the comment section below. Before you go, please hit the like button and subscribe to my channel. Thanks for watching.